Hello and welcome to another episode of Starting Out with Quantum Computing. I'm your host Lloyd, and I definitely know that I've got an interesting one for you this time. So we're talking about today, can quantum GPS help Santa deliver presents this year? Quantum navigation, it's an exciting and upcoming technology. With its potential advantages over standard GPS, could it help Santa deliver the presents? So what is quantum navigation? Can't we just stick with the sat-nav? Well, let's start with an overview of GPS, or the US Global Positioning System. It's a satellite-based navigation system owned and operated by the United States Space Force, providing geolocation, velocity of a vehicle, and time information to all users. It was first started by the US Department of Defense in 1973 and was originally only used for US military purposes. Ivan Getting, Bradford Parkinson, Roger Easton, these are all the main researchers behind GPS. And their first invention used a network of 24 satellites in space to align and position a target on the Earth. These satellites were sent up to space between 1978 and 1985. And in 1983, GPS was made publicly available, and since then, 6 additional satellites have been added. But the lesser-known force behind GPS is actually someone known as Dr. Gladys West, a researcher who grew up in rural Virginia and is known for creating a model that makes GPS functional today. Although the Earth can be thought of as basically a globe, its true shape has mountains, valleys, and oceans, and is much more complex. Dr. West's algorithmic approach to reproducing the shape of the Earth was so precise that it was instantly incorporated into the GPS. However, because she was a black woman in the 1970s, she was not largely acknowledged until more recent years. Over the years, GPS technology has become increasingly accurate, and most instances of GPS today are correct to within 5 meters. By combining Wi-Fi positioning, one can increase this accuracy even more. This makes current applications of GPS very useful indeed, from navigational maps in cars to drones and planes in flight to weather warning announcements and natural disasters. But GPS has a fundamental problem. The thing is, normal GPS systems aren't actually that foolproof. GPS can be susceptible to accidental or deliberate spoofs, causing it to fail. For example, almost 50,000 spoofing incidents occurred on aeroplanes in 2022, which was a five-fold increase from 2021. We call such incidents GPS denial. These are situations where GPS signals become unreliable or inaccurate for a receiver due to natural or unnatural interference. And to understand the daily scale of this, I would very much recommend going to a website called gpsjam.org. Here you can take a look at GPS interference on a day-by-day basis. So what can we do about GPS systems when they are so fragile? Quantum navigation. It's an exciting new field, and it uses quantum sensors to allow users to travel securely across the world. Whilst traditional GPS relies upon a signal being sent to and from a satellite, quantum navigation measures the movement of a single atom contained within a cryogenic box. This means the navigation is calculated within the personal vehicle, rather than relying upon a global system in space. To deliver quantum navigation, we can alter the quantum properties of a tiny atom, such as via quantum entanglement or quantum interference or superposition. And we can combine these processes with atomic clocks and proprietary software analysis to replace GPS entirely. Companies are already starting to incorporate quantum navigation into their products. Q-Control, for example, currently sell a product known as Ironstone Opal. It's their latest robust quantum navigation tool that can be incorporated into drones, autonomous cars, and commercial aeroplanes. They are reliable and unjammable, as they make use of the variations in the Earth's magnetic and gravitational fields in order to traverse the globe. This approach doesn't rely on any externally emitted signals and is instead internally calculated, meaning it can't be spoofed easily at all and can work in any set of conditions at day or night. The British government hope that quantum-based positioning, navigation and timing, which is colloquially known as PNT, will be a piece of the puzzle towards preventing spoofing on commercial flights. In the larger perspective, the British government, along with the Ministry of Defence, will be looking into how these types of quantum technologies can be used to help secure British interests and developments. So, how does quantum navigation work, put simply? Well, let's take an example from the US-based company Inflection, who are currently developing quantum gyroscopes and quantum accelerometers, which track a vehicle's bearing and distance travelled, respectively. Both these types of sensors rely upon a technique known as atom interferometry. This is a process where a beam of atoms is split into two by lasers and then later recombined. If a travelling vehicle has turned or accelerated suddenly during the splitting, then the two paths will be slightly out of sync when they recombine, and we can reverse engineer this to work out the vehicle's current location. It's very clever. In May 2024, Inflection partnered with BAE Systems and QinetiQ, spelt with two Qs, to complete the world's first commercial flight using advanced quantum-based navigation systems that cannot be jammed or spoofed by hostile actors. This was an incredible achievement, and the project received a backing of nearly £8 million from the British government. Science Minister Andrew Griffith commented on this. He said, "From passenger flights to shipping, we all depend on navigation systems that are accurate, safe and secure. The scientific research we are supporting here could well provide the resilience to protect our interests." Another researcher, Alison Keeley, at Swinburne University in Australia, is working on quantum navigation hardware that taps into the unique gravitational and magnetic fields of the Earth. By using a specifically altered diamond, known as a nitrogen vacancy diamond, the quantum state of certain electrons within the material become hypersensitive to changes in the surrounding magnetic field. One can carefully simulate and stimulate these electrons and watch how they emit certain types of light, matching this phenomena to known magnetic field strengths. We can also ascertain the direction of the magnetic field from these diamonds, which can be used to improve determining location. And as a final example, in 2024, researchers from the Centre for Cold Matter at Imperial College London tested a quantum compass on an underground tube on the District Line. Dr. Joseph Cotter and his team took a huge stainless steel chamber filled with rubidium atoms and lasers onto the tube, allowing for the inside of the chamber to cool to near absolute zero, which is about minus 273 Celsius. When these clouds of atoms are exposed to certain lasers, they become ultra cold and freeze, and they exhibit quantum mechanical properties at these temperatures that reveal information about how far the device holding them has moved. And so the ultimate question is, will Santa be able to deliver presents this year? Even though global GPS signals are being spoofed and mixed up almost every day, the sector of navigational technology continues to grow at an incredible rate. Quantum navigation promises a revolution to the way we travel across the world. These amazing sensors can track motion and location without relying upon external signals, meaning that they can work in all types of vehicles, both above and below the ground, even underwater in submarines. Such robust equipment can benefit so many industries. It will certainly benefit transport and defence, but it will also benefit mapping and emergency responses to natural disasters. So if you ask me, I think Santa will manage this year. As long as Santa takes a lesson or two in quantum mechanics, he might open up a textbook and perhaps purchases a quantum sensor for the sleigh. Christmas presents will definitely arrive at your tree, as always. I would very much like to say a big thank you and a Merry Christmas, reader and listener. It's been so much fun this year writing and doing the podcast for starting out with quantum computing, and I've been so lucky to write and to speak for you all. And I'm very much looking forward to next year, where I will continue to explore the world of quantum computing and all the associated quantum technologies and speak about it right here. So thank you very much for sticking around. Have a very merry quantum Christmas, and I will see you in the new year. Until then, bye-bye.